This is a conflicts passage. We know it's conflicts because it compares scientist 1, scientist 2, and scientist 3. Conflicts passages will compare scientists or students, sometimes hypotheses or methods. For the DRC approach, C stands for conflicts, and that's carefully read. I find for most students, it's better if they spend more time in the passage, then the questions are easier. There's only one conflicts passage per test, and you treat it like a reading passage. So if you remember, your goal is not to answer every question, but to maximize correct answers. So for some students, if you are a weaker reader or a weaker test taker that doesn't have time to finish, you might want to skip the conflicts passage altogether. Use your time on the other passages. So you should take about 3 to 4 minutes to read the passage and then another 3 to 4 minutes to answer the question. You have a little less than 7 minutes to do this entire passage, but I find the questions are generally faster if you understand the reading on this passage. First step is to identify the conflict, which is found in the first paragraph. And in this one, it talks about mass extinctions being caused by bombardments of Earth by comets, and 3 scientists share their viewpoints about the possible causes of the bombardments. So what are the causes of a bombardment of comets to hit Earth causing mass extinction? Step 2 is to identify the differences. We're going to start with scientist 1. I often find it helpful to draw and underline. So scientist 1 said the sun is orbited by a dim, unseen object called a brown dwarf, an object that is less than 0.08 times the sun's mass. So I drew the sun, and then I just drew an object 0.08 times the mass. Each complete orbit takes 26 million years, so I'm just going around the sun, 26 million years. Once each orbit, the brown dwarf passes through an Oort cloud that alters the orbits of the comets. So it goes through a cloud and it scatters the comets, causing many of them to enter the solar system. So it looks like that. These were my drawings when I took the test. Scientist 2. The sun is part of an open cluster of stars in which the stars are bound to each other by gravity. So I just drew a cluster of stars, and then the sun revolves around the center of the mass once every 26 million years. That's similar to scientist 1, both had 26 million years. Once every orbit, the sun passes through the densest part of the cluster. So the gravitational force exerted by the stars in this part of the cluster causes many comets to leave the cloud. So it's similar to scientist 1, but a little bit different. So there's my drawings. And then scientist 3, our galaxy is disc-shaped, and the sun lies within the disk. The galaxy also contains high-velocity stars. So I put arrows with my stars to mimic high velocity. My drawings just have to help me remember this for a short time. The bombardments that produce mass extinction are caused by gravitational effects of the high velocity stars. High velocity stars cause bombardments whenever these stars pass near the Oort cloud. So there's my cloud. When they get close to it, it causes bombardments. So all the Oort cloud has to do with the bombardments in all 3 of them. It does not occur every 26 million years, right? Rather than occurring every 26 million, it's at irregular intervals. So I wrote irregular. The sun cannot be part of an open cluster because the sun is 5 billion years old and clusters all form at the same time. So I'll put irregular and same age. So there's my drawings to help me remember what I read. And then we go to the questions. Question number 1. Based on scientist 3's viewpoint, which of the following quantities is approximately equal for the stars in the cluster? We know they're all the same age, so it has to be choice C. It says it, and we wrote it, so C. Number 2, based on scientist 3's viewpoint, high velocity stars pass through or near our solar system. This one's at irregular intervals, so irregular, so choice F. Number 3, suppose the last mass extinction occurred 13 million years ago, based on scientist one's viewpoint, the next mass extinction would likely occur how many years from now? Well, every 26 million years it passes through the Oort cloud. So if it passed through 13 million years ago, it's going to be another 13 million years. So B. Number 4, scientist 1 implies that the unseen object might be observable from Earth if the object, okay, so this one's a little bit tricky. It says it's 0.8 times the sun's mass and therefore not massive enough to become a star. So it can't be seen. So if it were a star though, it could be seen. So the answer would be H. That one's a little bit tricky to think about, but H. Number 5, the viewpoints of scientists 1 and 2 are inconsistent with that of scientist 3 regarding which of the following factors. So how is scientist 3 different? And the main difference, there's lots of differences, but how regular brown dwarfs form isn't talked about. Whether comets cause mass extinction at regular intervals. Scientists 1 and 2 both say it's every 26 million years, and scientist 3 says irregular intervals. So your answer has to be B. Number 6, proving the sun is part of an open cluster would directly contradict a statement made by which scientist? So scientist 2 says the sun is part of an open cluster, so it would not contradict scientist 2. Scientist 3 says the sun cannot be part of an open cluster, and scientist 1 doesn't say anything contradictory about it. When it contradicts, doesn't even talk about the sun being a part of or not being a part of an open cluster. So it only directly contradicts scientist 3, G. The stars in an open cluster are bound together by gravity. Scientist 3 supports the conclusion that the gravitational force of an open cluster is. Okay, so scientist 3 says that they drift apart after a few 100 million years. So that means the gravity is not holding them together. So they're too weak to keep the cluster together indefinitely. So all of the questions from this one are evaluations of models, inferences, and experimental results. So all in one category. Reach out if you have any questions. We'll end on a silly joke. You know, I don't really like thinking about gravity. You know, it really brings me down. Y'all have a good day.